Okay, Assalamualaikum warahmatullahi wabarakatuh. So this is our third video for chapter 5. So this is 5c. We'll go to 5.3 continuous least squares polynomial. So for this one, the difference is that instead of you're given the discrete data table, you're given an equation. So it's continuous equation. So I'll skip direct to page 70. Okay, so this is the formula, the general formula that we are going to use. So it depends on the number of power of n. Yeah, this one. So kita kena create this matrix based on kuasa m yang dalam soalan suruh. Okay, so this is the steps. First, you need to determine degree of m. Nak degree 1 ke, 2 ke, 3 and so on. So you must read the questions very carefully. Or if in ordinary cases, we decide which degree do you want to solve it with. So let's say you have m degree of the polynomial. Then what you need to do is to create this p polynomial m x. So kalau dia degree of 2, so sampai sini je lah. A0 plus A1x plus A2x power of 2. So kita habis kat situ kalau degree 2. Kalau degree 1 sampai x power of 1. Kalau degree 4 sampai x power of 4 and so on. So you need to create this PMX. Okay. Next is to create your normal equation in matrix form. Yang tadi itulah yang macam sebelum ni. Okay. Next is to solve for A0, A1 up to AM. Depends on the power of degree that we are using. The last one is to create the least squares function yang kita nak tadi. So sampai kuasa berapa yang awak tadi lah selanjutnya, dan kita substitute all the values that we have calculated. Okay. I'm not going to go to example 3 because that is a very general one. In order for us to identify the formula, the matrix. So I'll go direct to example 4 on page 72. So the question asks you to find the least squares polynomial approximation of degree 1. So it already stated here, they want the answer in terms of degree 1. 2, this is fx. You are given fx equivalent to x squared plus 4x plus 4. So this is not a discrete data. This is a continuous data function. A function must be continuous. So on the interval, it must give you the interval from a to b. For this one, it's from 0 to 2. So for this particular procedure, you need to create this matrix, normal equation, using integration. So integration from A to B, from 0 to 2 in this case. So in terms of the function itself, okay, this one, if you remember, discrete is n, then you got summation x. Summation. Okay, you have this summation. Let me show you. Okay, you have this n, you got your xi, x power of 1. So the x power of 2 and so on. So dalam kes ni boleh lebih kurang sama. Cuma you need to create in terms of integral. From 0 to 2, this one is your basically your n. Dalam kes ni 1 lah. Tak ada, kita tak kira n tu, tak ada n. So 1 dx. Lepas tu, this one is x power of 1 dx. X power of 2 dx. This is one x power of 1. Sama. By concept dia macam sama. Dan dalam konteks pattern dia tu. Okay, then you have your A0, A1. Then you have your y is fx. So fx dx. This kalau sebelum ni is yi. Okay, so this one kita dah ada function, so kita gunakan fx dx. So next is x fx dx. So kalau benda ada 3, dia akan ada x squared fx dx and so on. So since this one sampai 2 by 2 matrix here, so kita end up sampai sini je lah. So then awak selesaikan macam biasa integration. Integration. So misalnya yang ni dalam kes ni just masukkan je lah. I'll create. Okay, you create 0 to your fx is your x squared plus 4x plus 4 dx. So selesaikan. Kau tak boleh guna calculator direct from 0 to 2 yang ni. Dari tu dapat jawapan. Ataupun you selesaikanlah x33 4x squared 2 4x dan masukkan 0 to and so on. So katakan dah dapat jawapan. So untuk this one you got 2 of course yang sama 2 then 8 over 3 A0 ni tak ada apa kita nak cari. So this one end up you can use direct calculator again macam saya cakap tadi. You should have this one, this value. So once you have identified A0 and A1, Ini pun direct calculator again, macam sebelum ni. You can regression, set for regression or statistic, depends on the model of your calculator. Lepas tu once you have identified A0, A1, dan masukkan je dalam kita punya tadi equation PMX tu. Yang tadi kita buat ni, yang this one. PMX, masukkan value tadi. So that's it. Kalau tak pun yang ni awal-awal mesti ditulis kat depan ni lah. Sebab kita tahu nanti. Okay, we are targeting for our A0, A1. So kita buat steps ni bukan sama je. Cuma when it comes to continuous, we relate to integration from A to B. Okay, look at example 5. Okay, I'll go direct to example 5. Example 5, the difference is that we are setting our PMX into degree of 2. Okay, so degree of 2, so you need to set your PMX into A0 plus A1 plus A1x plus x squared x power of 2. Okay, and for this one is interval from 0 to 1, and your function is e power of x. Okay, so okay, these are the steps. Okay, tadi kita dah explain these two lines. So this one you need to create, since this one is degree of 2, degree 2, degree of 2. So our matrix will become 3 by 3 matrix. Okay, so ada first is dx, so x power of 1, this is x power 0 lah. X power of 1, x power of 2. Lepas tu dia ke sini, masuk kat sini dia naik lah 2, 3, 4 kuasa kan. Lepas tu sama juga, it goes x power of 0, x power of 1, x power of 2, x power of 2, x power of 3, x power of 4, x power of 1, x power of 2, x power of 3. So dia dah ada pattern dia tertentu. So for this one also, your fx, this is your fx given ex, so masukkan, lepas tu darabkan x squared, 3 by 3. Lepas tu next is to solve it lah kan. Kalau misalnya yang ni, so ke 0 to, so you get your x squared tadi ex dx. Okay, dan selesaikan. So katalah dengan jayanya dia dapat. So let's say you have already created this normal equation with all the values from the previous one, this one. Okay, so again you can use your calculator. Okay, so buat betul dapat direct just masukkan value ni dalam bentuk matrix if you are using that 570ES. Okay, so boleh masukkan direct bentuk ni, bentuk matrix. Okay, so masukkan value yang dia akan auto kira lah nanti. Try tengok dekat try to look at the video that I've given you before, how to use it for 3 by 3 matrix and also for 2 by 2 matrix. So you will directly get this 3 value, A0, A1, A2. So it's much easier. You will save a lot of time, because it's not easy to solve 3 by 3 matrix using Gauss-Elimination methods or even Cramer's. Even though Cramer's is slightly easier, but it still will take a lot of your time. So use your calculator. So you'll get this one. Then once you get this one, just substitute dia dalam equation tadi. Your A0, A1, A2, and that's it. Conclusion. Okay. So that's it. So I'll stop here for chapter 5c. In our next video, we'll continue on 5.4. This one is again for continuous data, but we will be using Legendre. I'm not sure how to pronounce it, but Legendre polynomials. Okay. Assalamualaikum warahmatullahi wabarakatuh.